So the first thing we'll do is we'll start working with our images, which have been collected, in this case by UltraCam. They're 15 centimeter resolution. So you can see here, these are the raw images. They're not georeferenced. If I pull those up in a focus viewer and show you, so you can see here that there's absolutely no georeferencing associated with these images. So they're just TIFF files, and I need to put a project together in OrthoEngine. What I'm trying to get to with this project is I want to produce this seamless ortho mosaic, which you see here. So that's what I want to do. So, and just to give you the context, this is where we're working. This is Hamilton, Ontario. So let me just zoom in here. So we're at the western tip of Lake Ontario. If I zoom in to Hamilton, this is our mosaic that we want to create. I've chosen this location because it's a challenging location. It has both water and urban features in it. And you'll see when we start working on the mosaic that there's some challenges associated with that, and we can use some techniques to mask the water and mask the buildings for cut line avoidance and so on. So I'm going to open up OrthoEngine and I'll start a new project. It's an aerial photography project. It's digital, and I'll compute the GCPs and tie points. I'll give it a name, so it's important to kind of stay organized. So let me go to my folder here. I'll put it in the top, the root of this working folder that I'm in right now, and I'll call this Hamilton. So I'll give it a description. All right. First thing it's going to do is it's going to ask me for the output projection. Now I know in this case from the data vendor that the information is available, so I'll go ahead and pick it. It's essentially they're using NAD83, so I'll go and select my datum. And the UTM zone is 17, and we're in the northern hemisphere. The output resolution, as I mentioned earlier, is 15 centimeters. I can set the GCP based on the output projection. In this case, I won't be using any GCPs. I'll just be using tie points, but I'll put that in those units as well. Okay, the next thing it's asking for is the focal length. So if I go, typically with air photo projects, you are given some ancillary data. So if I open up the camera calibration file, which came with the data, you can get these parameters here. So here's the focal length, so it's 105.2. The principal point offset in the Y is 0.27. It's 0 in the X. All of the rotation parameters are 0, and then the chip width is 103.5 and 67.5. And then there's the Y scale here, which I can also provide. So that's that. So the next step is to provide the data. So let me open up the images. These photos will be ingested to PIX file on the first attempt. So I've already done that, so I'll just go ahead and open the PIX files. But this will convert it to PIX, which will just make things go smoother. So I'll close that down. So those are my images. Then the next step is to import the exterior orientation. So the exterior orientation is providing information about the center point of the photo based on the calibrated instrumentation that's on board, the GPS and IMU. So this is the file here, and I'll just open it up so you can take a look. Basically provides the file reference name, the X, the Y, and the Z in this case, and then the omega phi kappa values for the positioning of the data. So I'll just browse to that location and I'll get that file. And for the accuracy here, I can do 0.5. Put this at 1, 0.2, and 0.5. And then I could just go import, and there you go. So basically now my project is set up and I'm ready to go. So I'll go ahead and take a look at my overview to make sure that everything ingested properly. So you can see that my flight lines are well organized. So this project includes, I think it's 60% forward overlap and 30% side lap. So this looks pretty normal. Okay, the next step is essentially to tie these images together. So the way that we do that in this case, as I mentioned, I won't be using any ground control. What I'll be doing is just collecting tie points. So I'll open up the tie point collection panel. I'll select only the overlap area because I'm using only tie points. The only location where I can get tie points is over the overlap area. I'll choose the grid method. This will try to avoid things like placing points on buildings, and it'll distribute them more evenly. And I can point to my DEM, so in this case I do have a DTM of the location that's been actually provided from this data. We extracted our own DSM and produced a DTM out of it. And I can go ahead and just go ahead and collect. Okay, so there you go. We found 500 tie points, which is more than enough, and let's go take a look at them. So a nice thing you can do is you can again bring up the display project overview. Then you can multi-select the images that are part of this project, and you can turn on the tie points. So you can see the distribution. We use the grid method, so they're evenly distributed, and you can even look at the displacement vectors for the tie points and get a sense of maybe where there's some larger errors and make sure that there's nothing too bad over certain areas. But probably the easiest way to groom the tie points, if you will, is to do so interactively using the residual report. One thing I like to do is just go to the GCP panel and just turn this on, this compute model option, and what that's going to do now is every time I make a change in the project, it's going to recompute the model. So I'll turn on the tie points, and you can see that right now my RMS is 1.28 and 3.04, which really is not acceptable at this point. So I'll start by, so these are sorted by the worst ones being at the top, the worst in terms of the RMS. So I'll just delete the first view here and see what happens. Okay, so my RMS, just by deleting those top ones, is down to 0.65 and 0.64, which is below 1 pixel, which is good. I've got a lot of tie points and I can do some more grooming, so I'm just going to sort of aggressively delete the worst ones here at the top. So I'm down to pretty good RMS overall. I'll try to get it down below 1. Okay, so all my RMS points are below 1 now, and my overall RMS is 0.1 and 0.4, so I'm pretty happy with that. I can hit compute model again, but it's computing the model automatically, as I mentioned. I'll just do a sanity check and make sure that I haven't destroyed tie points over scenes and that I have tie points over all of my images. Now recall that there's a big location in this part of the mosaic that's just got water, so probably we're not going to get tie points over this location. So I'm going to start the ortho generation step, so I'll go to the ortho generation part of the workflow, and you can see that I have all of my orthos here that I can produce. I will specify the DTM file that I've generated. I'll pick a location for my orthos to be written to, and then I'll just move them all over. And you can see that I'm ready to go, so I can go ahead and start that. Okay, so my orthos have generated, so let me take a look at them here. So I'll just load them up in focus to make sure everything's good. I'll just multi-select them and turn off the enhancement and zoom out. And you can see that at the moment I've got some issues in terms of color balancing. It looks like the water's got a bit of an issue, and in general this scene kind of looks a little bit darker. This scene looks a little bit brighter. So that's the next step. What we're going to do now is we're going to switch over to Python to generate an XML file that's going to allow us to do multi-user mosaic editing.